Good evening, students. Very warm welcome for another important, amazing class. How to write the electron configurations and what was the quantum theory which was given after the Bohr has done and studied the emission spectrum of hydrogen atom. You are aware that we have discussed with you students the hydrogen atom. Was it discussed? Hydrogen spectrum?
Yes, sir, it
Emission
was.
of certain specific and definite lines were emitted by the hydrogen atom. And spectrograph recorded these lines and wavelengths. And we shown you the lines were observed in visible, infrared and ultraviolet regions. ठीक है? Balmer, Bastian, Brackett, Pfund. These scientists and Rydberg has given a formula also general expression to explain the emitted wavelengths of the lines of the hydrogen atom. According to, on the basis of this hydrogen emission spectrum, Bohr proposed his atomic model in which what was said that there are energy levels, there are energy states, students, there are orbits in which the electrons are moving, and these are definite and only certain allowed energy levels in which electrons move, and so long as electrons move in these definite energy levels, their energy is not changing, but electrons can jump from lower to higher energy state by absorption of energy, or they can fall from higher to lower by emission of energy. That is why you obtained, you see, visible in the Balmer, Lyman in the ultraviolet, and other in Bastian bracket, infrared, far infrared region. We have shown you all these lines, students.
Yes, sir.
So on the basis of this, they were proposing a model of the atom. So then came the idea that there are, what we said, there are energy levels. What we said, there are energy levels on the basis of the line emission spectra. So students, what you are saying that by studying the line emission spectra of hydrogen atom, ठीक है? Bohr made his postulates, what we call as Bohr's atomic model, or they are also called postulates of the Bohr. So came the idea of, what was the idea? There are energy levels. Energy levels, students. There are energy levels, students, in which there are electrons, students, in order to explain these characteristics lines. And hydrogen atom is the simplest case. It has only one electron. How many electrons are there in hydrogen, student? Atomic number is 1. It has only one electron. So it is the simplest.
Yes,
And
sir.
the emission lines are available by the spectroscopic analysis. So these energy levels, we say that, okay, they are given by values n equal to 1, 2, 3, 4, and so on. So you are saying that electrons are present in this, and the values of the energy is increasing. This is increasing energy,
Yes, sir.
increasing energy. So students, this is the idea of the energy levels, or you are saying shells, or you are saying orbits,
Yes, sir.
and they are represented, when I say n equal to 1, you are saying it is representing K shell, first shell, n equal to 2, L shell, students, n equal to 3, you are saying M shell. Like this we can continue. This is actually a useful first approximation, I'm saying. First approximation, student. What is it? It is an first approximation for the location or the energy of electrons in an atom. However, when they analyzed students, when they analyzed the atomic spectra uh, and the spectra of other atoms, ठीक है? What was found is, students, that there are this is approximation is no longer holding true. So the emission spectra of atoms with more than one electron, what they studied further, emission spectra of atoms more than one electron, more than one electron, student, was studied, ठीक है? And ionization energy data was collected. What is ionization energy, student?
Ionization
Energy
energy.
required to remove one electron from a neutral gaseous atom is called ionization energy.
Okay, sir.
Further, it was found, student, what they observed, that these lines further split up into doublets. That the emission lines, and they used high resolution spectrograph, and it was observed that these emission lines were further split up into doublets. Therefore, the Bohr's atomic model or the idea of shells was not complete, was not complete. We can say that this is just a first approximation. I am saying first approximation.
Okay.
And what we know, that it was suggested, that what was suggested, there are sub energy levels, sub energy levels, in order to explain the spectra of atoms more than one electron, and also to explain the splitting of the emission lines obtained from hydrogen doublets were observed. Therefore, they said that the main energy levels are made up of sub energy levels, that there are main energy levels, which you are saying n equal to 1, 2, 3, and in them there are sub energy levels, students, sub energy levels. So we will tell you actually just some idea about how this idea came, because this could not be explained by Bohr's atomic theory, the idea of sub energy levels. And further, the electron sub energy levels, students, which there are the in Bohr's theory, the electrons are moving in fixed orbits or orbits, but there were student experiments which were done by Heisenberg uncertainty principle, and de Broglie, in which they found electron has got a dual nature. It is both a particle as well as a wave. And Heisenberg, after doing the experiment, came to the conclusion and found out experimentally it is not possible to find the position and the momentum of electrons simultaneously. And therefore, the idea of orbits is no longer correct. Idea of finding definite position of the electron in the shell is not correct. And then what happened, students? The theory was further improved by what we call as a quantum mechanical model. I will give you a small idea about that, because I don't want to spend too much time. That is not the purpose of us. So this was just the idea that these lines were observed, and on that basis, the Bohr has proposed student his atomic model. So what we are saying, there are energy levels, there are sub-levels and orbitals. Within the energy level, student, there are sub-levels, and in the sub-level, there are orbitals in which the electron live. And how the electrons will be found in the orbital, we will see that by using set of four quantum numbers, which are called principal quantum number, azimuthal orbital quantum number, magnetic quantum number, and spin quantum number. But the important point is, as the emission spectra of elements more than one electron was studied and further lines were resolved into doublets, it is observed that there are sub-levels and orbitals. So electrons exist around the nucleus in an atom in discrete specific orbitals. Electron cannot just exist at any distance from the nucleus. These orbitals are called levels and we number them as n1, 2, 3. This was the proposed by Bohr also, which I am saying n is equal to 1, 2, 3, 4 and so on. Okay? The levels can be broken down into sub-levels, students, sub-levels. And we have SP, D, F sub-levels. These are broken down into sub-levels. These are my energy levels, students. In the energy levels, we have sub-level student, which are represented by L, 0, 1, 2, 3, and they can have value up to n minus 1. So, for example, I'm going to tell you something about quantum numbers also, how this has been given. If L is 0, this is called s orbital. When L is 1, it is called p orbital, this is called d orbital, and this is called f orbital, and so on. So we can say that the sub-levels are which one? What are the sub-levels in the level, student? S, P, D, F. And level 1, in the energy level 1, student, in the energy level 1. What is the energy level 1? N equal to 1. In n equal to 1, we have S subshell. Okay? Only. S subshell only. And this is your K shell. K shell. And if n is equal to 2, student, you have, this is 1s. We will show you how it is coming. If n is equal to 2, you have 2 subshells. There are 2 subshells in the second. If n is equal to 3, student, there are 3 subshells. 3s, 3p, and 3d subshells. Please note down everything because it will help us in writing the electronic. When n is equal to 4, student, there will be 4 subshells. We are saying 4s, 4p, 4d, 4f like this. These are the subshells, student, spdf. So there are n equal to 2, you have 2s, 2p subshells, 3s, 3p, 4s, 4p like this. There are subshells which are present in the energy levels. And these sub-levels contain orbitals, students. In the sub-levels, there are orbitals, okay? And orbitals are spaces that have high probability of containing an electron. So we are not saying there are electrons are not present in the orbits, they are present in the orbitals, means probability of finding the electrons around the nucleus is maximum in these orbitals. And for example, we are saying there is s orbital, student. So s orbital is representing an area where the electrons live. And in one orbital, student, in one orbital, only 2 electrons can be present. Maximum electron in one orbital is 2 electrons. And there are rules which we are going to tell you that how these 2 electrons will be there. These electrons will have to have opposite spins to exist in a particular orbital. And how many orbitals are there? S subshell has only one orbital. How many orbitals are there, students? What we are trying to tell you, students, for writing the electronic energy, you are saying S orbital, student, there is S has only one. S subshell, S subshell has only one orbital. P is a subshell, it has 3 orbitals. I may represent it by a box. It is only one. P has three. I'm saying these are three P. A box representation of P. P has three orbitals. These are orbitals. D subshell has student five orbitals. How many? Five. If I represent rooms like this, one, two, three, four, five orbitals. F subshell has students seven orbitals. How many? One, two, three, four. One, two, three, four, five, six, seven. And in each orbital, how much? What is the maximum electron in each orbital? Only two. Each orbital can have students. How
Only
many?
two electrons.
Each orbital can have two electrons of opposite spins. What is spin? We will tell you. We represent it like this. One is like this, other is like this. Opposite spins. Electrons have spin, student. They have to be opposite. There are rules for filling the electrons. We will explain to you those rules. It is just like this, student, that atom, atom, for example, supposing I have to come to your house, student. You are living in some area, that is the name. After I reach your building, student, I have to see which floor you are living, student. Then I climb to your floor. After that, inside your home, you have rooms, student, different rooms. They are the orbitals. In each room, supposing you put two beds. So maximum person that can sleep in one bed is two. So there are the same type of situation. Here we are saying that there are energy levels. In the energy levels, there are sub levels, and in the sub levels, there are orbitals. And each orbital can have maximum of two electrons. How many suborbitals will be there in any shell? That is given by what we call as quantum mechanics or quantum theory. Just to get you an idea, student, this is the order which we have shown of the increasing energy of these sublevels. The first shell, I am saying this is my first shell. This is my first shell. What is that? N equal to 1. Okay? N equal to 1 is your first shell, student, which we called as K shell. Okay?
Yes, sir.
It can have only one subshell. Which one is that? 1s. First, this N equal to 1 first. And maximum electron in it can be 2 only, because it is only one orbital. If N equal to 2 students, then it can have two subshells, which are those 2s and 2p. And 2s is lower in energy than 2p. And 2s, I have shown only one. So only two electrons can be accommodated in this. After this comes the 2p. In 2p, there are three orbitals. So how many total electrons I can put in 2p, student? 2 plus 2 plus 2. How many? 6.
6.
Here you can put 1 and 2. Here you can put, student, 1 and 2. Here 1, 2, 3, 4, 5, maximum 6. It is filled. Then I will go further. 3s is lower in energy than 3p. How many I can put in s? Only 2. How many I can put in p, students? How many? 1, 2, 3, 4, 5, 6. So maximum electrons in S is 2. Maximum electron is P is 6. Then 4s is, after this comes the 4s. How many you can put here in S? 2. Then 3d. 3d is how many orbitals? How many I have shown for 3d? D. 1, 2, 3, 4, 5. 5 orbitals. You see the 5? So how many maximum electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in D, maximum electrons can be 10 students.
Yes, sir.
And 4p again 6, 5s, 4d, and when you will get further to 4f students. How many orbitals have drawn for 4f? 7. So in 4f, how many you can put? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many? 14. So students, I can say maximum number of electrons, student, in S is 2, in P is 6, in D is 10, and in F is 14. Okay? These are the subshells which are present in the shells.
Hmm. Yes, sir.
S, P, D, F are the subshells. And in S, how many orbital? 1. In P, how many orbitals? How many orbitals in S? Number of orbitals. In S, how many orbitals are there? In S, student, only 1.
Only one.
In P,
Two.
3. Where 3? I have
Three. Three.
in P, 3. In D, how many?
There
5.
are four. Five.
In F, 7.
There are seven.
So into 2 number of electrons. Because in one orbital, how many electrons can live? 2.
Two.
With opposite spins. With opposite spins. So we are now getting some idea that how the electrons will be filled, student.
Sir, why is it necessary for a single orbital to have opposite
I am
electrons?
going to explain. I am just giving you the idea. After the emission spectra are studied, student, they have got an idea. Yes, only energy level which are given by Bohr is only a first approximation. And there are subshells, there are orbitals, and how these subshell orbitals come, I will explain. Okay? I'm going to explain you all this. First, you come up to now, you have understood what I have tried to say. Because it is not possible to go in detail for all the theory. Quantum mechanical theory is there, which has given us 4 quantum numbers, on the basis of which these we are giving the building of the distribution of electrons in an atom. So what is the minimum I can do? I will do it, because in full detail we cannot go as per your syllabus. Okay? In other words, student, here is a small picture I have shown. The first level is K, K1, n equal to 1. The orbital, only one orbital in the first.
Yes, sir.
And how many maximum electrons? 2. When n is equal to 2, this is n equal to 1, student, this n equal to 2, n equal to 3, n equal to 4, like this. Then in the second, when n is 2, you have 2 orbitals, two subshells, okay? Sublevels. In the sublevels, there are 2 orbitals, S and P. In S, you will have one orbital, total number of orbitals. This is a total number of orbitals. In P, you have 3 orbitals. Okay? So
Okay, sir.
total orbitals, how many in n equal to 2? 1 plus 3, 4 orbital. So maximum electron, 4 into 2, 8. If when n is 3, in the third shell, you will have 3 sublevels, 3 subshells, S, P, and D. And in S orbital, what is the number of orbital in S? Only 1. What is the number of orbital in P? 3. What is the number of orbital in D? 5. How many? Total 9. If there are total 9 orbitals, how many electrons can live? 9 into 2, 18. Okay? Noted? Tell me. Any doubt? We are trying to find what is the maximum electrons which will be there in first shell, in second shell, in third, in fourth, and so on. Okay? It is dependent on the number of orbitals which are available. We have already told you maximum electron in S2, maximum electron in P6, in D 10, in F 14. Okay? Can I proceed further? Tell me.
Yes, sir. You can proceed further.
Okay, this is just this. You will get the complete video also on this. Let me get you something why we are doing all this. Actually, student, The Bohr's model or Bohr's postulates were given after studying the emission spectrum of only hydrogen atom, which contains only one electron. But when more atomic spectra were studied, they observed that it cannot be explained on the basis of energy levels. And therefore, there was a need of some model student other than, higher than, better than Bohr's model. Okay? So that
Yes,
is
sir.
called the quantum mechanical model of atom. What was given, student? Quantum mechanical, okay, model of atom. And this student, there is a scientist called Schrödinger. Schrödinger is a mathematician. He was awarded Nobel Prize also. He was the one who gave mathematical derivations of this quantum mechanical model. And there are two important experiments which were actually a result of this. One was Heisenberg uncertainty principle, students. I'm not going into detail of that. It is not given in your course, so I'm not doing that. But he found that it is not possible to determine the position and momentum of electrons simultaneously. Second was de Broglie's wave equation. What he said that every particle is associated with a wave. He said electron is not only a particle, it has a wave properties also, students. The dual nature of, just as there is a dual nature of everything, every matter is a wave also. So after that, Schrödinger was the scientist who did a mathematically solved quantum mechanical model of atom. Okay? The name is associated with Schrödinger, who solved these equations Shrodingr. He has given an equation, students, in which he said the energy of electron in atom is quantized, can have only certain specific values. For example, when electrons are bound to the nucleus in atom. That Bohr is also saying the same thing. The existence of quantized electron level is a direct result of wave-like properties of the electron, because electron has a wave-like properties. That is why not all the energy levels are allowed for the electrons. Both exact position and exact velocity of an atom cannot be determined. This was proposed by Heisenberg. The path of electron in an atom is therefore can never be determined or known accurately. When the path of electron cannot be determined accurately, student, then what we say that what is the best probability, highest probability of finding the electrons at different points in an atom. So came the idea of orbitals. What is an orbital, student? Probability of finding electron around the nucleus. Around the nucleus. These are called orbitals. S orbital, P orbital, D orbital, F orbital, which you are defining. Those are the places where the probability of finding the electron is highest, students, because the exact position cannot be determined. Further, student, an atomic orbital is a wave function which is represented by psi of an electron. Whenever electron is described by wave function, we say that electron occupies that orbital. That is how we will represent as the electron is in S orbital, in P orbital, in D and F. This is all given by quantum mechanics, student. Mathematically, we cannot go into details of that, but we will assume there are four set of quantum numbers which are the result of the Schrödinger's wave equation, and we will use those four quantum numbers in order to build the electronic configuration of the elements which are in our periodic table, students. So we'll learn those rules. Okay. Since many such wave functions are possible, there are many atomic orbitals in an atom. A atom has many atomic orbitals because they found mathematically many wave functions are possible. So many atomic orbitals are possible. The probability of finding an electron at a point within atom is proportional to square of the orbital wave function. From the value of psi square at different points within an atom, it is possible to predict the region around the nucleus where electron will be most probably found. That is what we call as orbital. So students, now we are saying that there are orbitals, not other orbits in which the electrons can be obtained. Where? Orbitals. What is orbital? Where the probability of finding the electron is highest. ठीक है?
Okay, sir. Yes, sir.
So after solving the mathematical Schrödinger wave equation, student, we will get 4 quantum numbers, which all these 4 quantum numbers will provide us complete address, complete information of the electron in an atom. Because there is not one electron, there are many electrons in different elements. You know, atomic number is equal to the number of electrons. Hydrogen has 1, carbon has 6 electrons, oxygen has 8,
Yes,
nitrogen
sir.
has 7, sulfur has 16. So according to their atomic number, then where are these electrons present inside the atom, student? They will be their electron configuration or their address, because each shell has a definite energy. The electron is moving with a definite energy in that orbital, student, orbital in that particular energy level. So all this information is available by set of 4 quantum numbers. How many quantum numbers are necessary to define the state of electron in atom? 4. Where they come from? Quantum mechanical model of the atom. And what is that quantum mechanical model solved? Schrödinger's wave equation. It is mathematical. And we are not going into full detail of that, but I am telling you short. First is called the principal quantum number, N123. This gives you the energy level, N1, 2, 3, 4. This is our K shell, this is our L, M, N, and so on. This is first energy level, student. This is second, this is third, this is fourth, and fifth. This gives you the energy of the electron. This level will give you the energy of the electron in the first shell. This will give the energy of the electron in the second, third, and so on. So this is the first energy level. What we call it, student? Principal quantum number. Have you noted down first quantum number?
Principal. Okay, wait.
Principal quantum number n, student, is the first shell which we should know, which I have said. This determines the size of the orbital and the energy of the orbital. This orbital determines, students, size of orbital. Electrons are present where? In the orbitals. What is an orbital? Probability of finding the electron is maximum. This determines the size of the orbital and energy of the orbital. Energy of the orbital. This is my principal quantum number, first one. These are the energy levels which were given by Bohr. Same thing, energy levels. This was proposed by Bohr, and first energy level, second, third, fourth. Okay?
Yes,
So
sir.
this is represented by M. And we are saying there are n subshells in the n. And the subshells, second one is saying azimuthal quantum number. This is also called orbital angular momentum. It defines the 3-dimensional shape of the orbital, students. This is defined by a value L. L can have value 0, 1, 2, 3, and maximum n minus 1. N minus 1. Supposing if n is 1, student, then what will be the value of n? L. It can have n minus 1. 1 minus 1 will be 0. It can have only one possible value. And this L equal to 0 is called the s orbital. L equal to 1 is called the p orbital. L equal to 2 is called the d orbital. And L equal to 3 is called the f orbital. So if n is equal to 1, then there is only one value L equal to 0. So it is, we call it 1s orbital. That is our 1s student, only 1 n equal to 1, s is 0. If n is equal to 2 student, then what can happen? L can be 0 and maximum value is n minus 1. 2 minus 1 will be what? 1. So it can have two values. If n is 2, there can be two subshells. How many? Two subshells. When L is 0, what you call is n is 2, L is 0. It will be 2s. N is 2, L is 1. What is 1? 2p. So in the n equal to 2 students, you will have 2s and 2p, 2s and 2p orbitals, 2s and 2p orbitals. Similarly, I can take n equal to 3 student. If n is 3, L can have 0 and 1 and maximum 2 values. N minus 1, 3 minus 1 is 2. What is this? N is 3, so I say it is 3s, 3p and 3d. Similarly, students, I can take n equal to 4, then L can have 0, 1, 2, and 3 values. So L is equal to 0, n is 4, this will be 4s, 4p, 4d, 4f. Like this, we are saying this is given by the quantum number L, which is called the orbital quantum number. So it gives the shapes of the orbital. Different orbitals have different shapes, student. They are derived mathematically. We will only show the shapes of them and how only Schrodinger equation can be solved to get the shapes of that. All right. So students, here what we are saying, what I am trying to show, that m equal to 1 is the first shell and the value of the subshell is 0, it is 1s. In the second you have 2s. In the second n equal to 2 you have two orbitals, two subshells, 2s and 2p. In when n is 3 student, you will have 3s, 3p and 3d. When n is 4 you will have 4s, 4p, 4d and 4f orbitals. So in the energy levels there are subshells. In the subshells you have
Yes,
orbital,
sir.
and how many electrons can be accommodated in each orbital, that we will see now. There is a third quantum number, student. It is given by the quantum mechanical Schrodinger's wave equation. It gives the information about the spatial orientation of orbitals with respect to coordinate axes. For example, if m is called the magnetic quantum number, it can have 2l plus 1 values, students. For example, if I and the values are ranging from minus L to minus L minus 1 to 0 to 0 to student L minus L to, this is my plus L. For example, if L is equal to student 1, then what will be 2L plus 1? Tell me. How many? 3? 3. That means what will be the possible values if L is equal to 1? 3 values. How many? How many are
Three
coming?
values.
3 values are coming. And the values are minus L, 0 to plus L. That will be minus 1, 0 and plus 1. When L is 1, what is that orbital, student? L is 1 means p orbital. Therefore, there are 3 p orbitals. You can see. If I get px, py and pz. That is how there are 3 p orbitals, students, which are given by the magnetic quantum numbers. They are given by the magnetic quantum number, students. When will be L1, student? If L, what values of L I gave you, it is 0 to n minus 1. That means n should be 2. When n is 2, L can be 1 or L can be 0. So if L is 1, then you will have ML value 3 values. So this will be n is 1. This I can say it is 2px, 2py or 2pz. So these are the orbitals, students, which will be there when L is 1, n is 2. Similarly, we can write the SPDFG subshell notations and how many orbitals are there. Here we have given when value of L is 0, student, this is called S, and in S there is only one orbital. For L equal to 1, p orbital, p, how many number of orbitals in p subshell? 3. In D, how many number of orbitals? 5. And in F, how many? 7, and so on. This much will not be needed for our course because how many elements you have in the periodic table? Maximum you are listed only 118, out of which only of your use is after 92, all are not made by man, they are synthetic and synthesized in nuclear reactions, unstable. They are unstable. So we won't need all these orbital students. Okay. Further, what I'm saying, up to now I have given you 3 quantum numbers. But then it was found that students, in order to explain the spectra, all the thing, experimental evidence is very important for anything. And the emission spectra is there. So students, up to now, I have given you 3 quantum numbers. What I have given you 3 quantum numbers. Which are those? N, L, M. This is my principal quantum number. I have given you principal quantum number. Then I have given you azimuthal or orbital quantum number. Orbital quantum number. Third one, I have given you magnetic quantum number. This was not enough to explain the lines spectra, student, of different lines, because they found the lines actually occur in doublets or 2 lines closely spaced together, or triplets, 3 lines closely spaced. So they said there is a 4th quantum number which is called the spin quantum number. Spin quantum number means what, students? That electrons can spin. Electrons have spin. Electrons have spin, student. They can spin in clockwise or anti-clockwise direction. This electron is spinning around its axis, student, electron. So it
Okay,
can
sir.
spin clockwise or it can spin anti-clockwise. So they defined a 4th set of quantum number in order to explain the emission spectra of different atom, students. So now we have 4 set of quantum numbers, N, L, M, L, S, in order to find the exact information or energy position of electron in an atom. These are the ones which we will use for writing the electronic configuration, students. How many quantum numbers? So there are, what we are saying, the energy levels N, then you are saying energy levels are there, ठीक है? Then there are sub energy levels, students. Then what are the sub energy levels which we have shown by L, ठीक है? Then we are saying there are orbital, students, and then the 4th one we are saying the spin of the electrons. So students, in order to write the electron distribution, we will use these 4 set of quantum numbers. What are these? Energy levels N, S, P, and you have been told how many maximum electrons can be put. So where the electrons are living inside the atom, energy levels. In the energy level, there are sub-levels. In the sub-level, there are orbitals. And in one orbital, only 2 electrons can live. And they must have opposite spin. Now the spin idea is there. And the 2 electrons cannot have the same spin because the rules have been proposed. What are the rules for writing the electronic configuration? That is our next point. That how to write the electron. Up to now, you have understood what I have
Yes, sir, I
said,
have understood.
that in order to explain the complete emission spectra of the different and multi-electron atoms, as lines actually occur in doublets or triplets. Therefore, the first approximation of Bohr, which is the energy level, is not enough in order to explain all this information. Therefore, there was a need of some energy levels, there was a need of orbitals. And where these come from, student, they have been given by quantum mechanical model of the atom. What I'm saying, quantum mechanical model of the atom, students, which was mainly proposed by Schrodinger's wave equation, in which he has defined a wave function, and the square of this wave function gives us the probability of finding the electron around the nucleus. And there were two major important work by Heisenberg consultancy and by the de Broglie, after which this became important. And this is a mathematical, all this is a mathematical, student, mathematical. Oh, they have calculated the wave functions with the position of the electrons in an atom. Since there are so many electrons, there will be different wave functions, and therefore four set of quantum numbers are required, student, in order to specify the state of an electron in an atom completely. Is it clear? Is it clear, students? Now, after we have got this four set of quantum numbers, we will be using certain rules for building up of the or filling up of the electrons in the atom. That how the atoms, how the electrons will be filled inside the atom. For this, we will be using, student, four important rules. Those important rules have been given. One is called the Aufbau principle. But I will use Aufbau-Principal, student. Then I will be using Pauli's exclusion principle. Pauli's exclusion principle, student. And third, we will be using Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity in order to write or the distribution of electrons in an atom. Up to now, do you understand what I said?
Yes, sir, I understood.
So students, we are stopping our lecture at this. In the next lecture, student, I will explain to you these rules which have been used in writing the electronic configuration, and we will write the electronic configuration of different elements, and on that basis the chemistry will become very easy, and we will be able to explain chemistry, chemical reactions by the electron distribution of the uh, electron distribution in atoms of different elements. That's why we are doing all this. For chemistry, what we need is where are the electrons in the atom, what are the valence electron, the outermost electrons, they are taking part in the chemical reactions, and we are using the idea, we are taking the help of these four quantum numbers. They are coming from quantum mechanical model of the atom, Schrodinger's wave equation, after doing mathematical calculations. So we will use how many quantum number? Four. N, L, ML, and S. Principal quantum number, orbital, magnetic, and also the spin quantum number. And if we show you the shapes of the orbitals, what are the shapes of the orbitals? See, mathematically, after doing the calculation, they have got the shapes of the orbital. This is the shape of the S orbital. You can see spherical symmetric.
Yes,
How
sir.
many S orbital is there? Only one S orbital is there. This is 1s, 2s, and how many p orbitals are there? Three. These are the three p orbitals. You see, they are like dumbbell shaped. Dumbbell shaped. What it is, it is the probability of finding the electrons around the nucleus. Where is the electron around the nucleus in the p orbital? This is the probability distribution. This is 2px, 2py, 2pz, three p orbitals. And the d orbitals are more complex. These are the 5d orbitals, students. The 5d orbitals, how many? 1, 2, 3, 4, 5d orbitals, dz square, dx square minus y square. Mathematically, they have solved the wave equation given by Schrödinger and obtained these. The probability, these are the orbitals in which maximum probability is there for finding the electron, students. So how many d orbitals? I told you 5. F orbital is more complicated, so we are not showing the pictures of that. So this is the shapes of the different orbitals. Which orbitals I told you? S, P, D and F. ठीक है? And then we will feed and find a scheme for writing the electron configuration by using which principle I told you? Aufbau,
Yes, sir. Obvo.
Pauli's, Hund's rule. And once we are able to write the electronic configuration of all the elements of the periodic table, we will start studying their chemistry using their electronic configuration. ठीक है? So
Yes, sir.
chemistry will become easy. Okay, then good night. I'll meet you in the
Good
next.
night, sir.
Okay.
Thank you.
I wish you a very, very happy new year. And
Yeah, sir. Same to you.
okay, student. Thank you very much. We'll meet you in the next class.
Thank you, sir. Welcome, sir.